Dear students, good afternoon, one and all present here. Today we are going to discuss about chi-square test. Chi-square test contain 7 parts. Part 1, 21.1 objective, 21.0 objective, 21.1 introduction, 21.2 chi-square test for goodness of it, 21.3 test for independent of attribute in consistency table, 21.3 2 cross 2 consistency table, 21.4 let us sum up, 21.5 keywords, 21.6 references and further reading, 21.7 terminal questions. Now discuss about 21.0 objective. What is objective? The chi-square test is an overall test for detecting relationship between two categorical variables. If the test is significant, it is important to look at the data to learn the nature of relationship. What is next one? Now we are going to see introduction. A chi-square test is a statistical test used to compare observed result with expected results. The purpose of this test is to determine if a difference between observed data and expected data is due to change, due to chance, or if due to relationship between the variables you are studying. The chi-square test is a statistical process used by researchers to examine the differences between category variables in the same population. For example, imagine that a research group is interested in whether or not educated level and marital status are related for all people in India. After collecting a simple random sample of 500 Indian citizens and administering a survey to the sample, the researcher would first manually observe the frequency distribution of marital status and education category with their sample. The researcher would then perform a chi-square test to validate or provide additional context for these observed frequencies. 21.2 chi-square test for goodness of it. Qi equal to 1, 2, 3, etc. n or set of observed frequencies, and I equal to 1, 2, 3, etc. n or the corresponding set of expected frequencies. Then the statistic chi-square test is defined as chi-square equal to sigma I equal to 1 to n, that is O I minus Ei whole square whole divided by E. The degrees of freedom b equal to n minus 1 for fitting a binomial distribution b equal to n minus 1, for fitting a Poisson distribution b equal to n minus 2, for fitting normal distribution b equal to n minus 3. Based on this above formula and conduct by using chi-square test to solve the problem. The problem 1, the following test gives the number of aircraft accidents that occur during the various days of the week. Test whether the accidents are uniformly distributed over the week. Days: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And number of accidents in Monday 14 and Tuesday 18, Wednesday 12, Thursday 11, Friday 15, Saturday 14. The overall accident in a week 84. Solution: let us assume that The accidents are uniformly distributed overall the week. Let us assume that the null hypothesis is not. Null hypothesis is not. The accidents are uniformly distributed over the week at 5% level of significance. By using them, the test statistics I square equal to sigma I equal to 1 to n OI minus EI whole square whole divided by E. The expected frequency on each day is equal to this total number of occurrence divided by number of days. This 84 divided by 6 equal to 14. The average accident in a week 14. That is observed frequency. Observed frequency 14, 18. This given data. The expected frequency expected accident in a week 14. That is observed frequency minus expected frequency 14 minus 14 0, this 18 minus 14 4, 12 minus 14 minus 2, 11 minus 14 minus 3, 15 minus 14 not 14. That is observed frequency, that is squaring 0 square 4 square minus 2 square. Similarly you can find in other. This the sum of, that is the calculated values of chi-square values. Sum of chi-square value equal to 30 divided by, that is expected frequency 14, 2.143. That is the calculated value of chi-square test is 2.143. The degrees of freedom n minus 1. Number of data, therefore 7 minus 1 6. Therefore 6 degrees of freedom at 5% level is 12.59. Therefore, the calculator values 2.143, table values 12 point. Therefore, the calculator value is 12 point, table value. Therefore, calculator value is less than the table values. Mean this null hypothesis lecture not is accepted. Accept the null hypothesis mean we conclude the accidents are uniformly distributed over the week. Next one, discuss about the next one problem. The theory predicts the population of beings in four groups A, B, C, D should be 9 is to 3 is to 3 is to 1. In an experiment among 1600 means, the number of four groups were 882, 313, 287, and 118. Thus, the experiment results support the theory. Here, the theory fits well into the experiment. Total number of beans 1600. Divide the beans in the ratio 9 is to 3 is to 3 is to 1. Calculate the expected values. Expectation of 82. Expectation of 82 is 9 divided by 16 into 1600 to 900. Expectation of 13 equal to 300. Expectation of 287 equal to 300. Expectation of 18 equal to 1100. Then observed frequency 882, 313, 287, 118. The expected frequency 900, 300, 300, 100. That is, we calculated sum of observed minus expected frequency whole square whole divided by E equal to 4.7266. Therefore, the table values of ChiSquare test at 5% level of 5% level is 7.815. Is therefore the calculator value is 4.7266 and then table value is 7.81. Therefore the calculator value is less than the table values. We accept the null hypothesis H0. Therefore the conclusion, there is a very good correspondence between the theory and experiment results. In 120 throws a single die, the following distribution of phases was observed. Phase 1, 2, 3, 4, 5, 6. Frequency phase 1 30, phase 2 25, phase 3 18, phase 4 10, phase 5 22, phase 6 15. Can you say the dice is biased? Here, the conclusion that is the setting the hypothesis, null hypothesis, the die is unbiased. Alternative hypothesis, the die is biased. The level of significance at 5% level. Degrees of freedom n minus 1 equal to 5. The phase 1, 2, 3, 4, 5, 6. Just apply observed values 30, 25. This is frequency. Phase this observed expected frequency. Therefore, 30 this observed 20. That is observed frequency calculated values 258 amount 258. Therefore, the calculated value of chi-square test equal to 12.9. The table values of chi-square test at a 5% level of significance equal to 11.09. Therefore, the calculated values greater than the table values. We reject the null hypothesis at 5% level of significance. Therefore, the dice is biased. Test for independence of attribute in a contingency table. Let us consider two attributes A and B divided in R classes A1, A2, etc. AR and B divided into S classes B1, B2, etc. BS. If this expected as R cross S matrix, the matrix is called R cross S contingency table. For a 2 cross 2 contingency table, chi-square equal to AD minus BC whole square into A plus B plus C plus D whole divided by A plus C, B plus D, A plus B, C plus D. Let us see the 2 cross 2 contingency table. Let A and B be the two attributes. Let A can be divided into A and B, and B can be divided into C and D. This from the table is A, B, C, D, that is A plus C, B plus D, A plus B, C plus D is the total. For a 2 cross 2 contingency table, expected frequency equal to row total into column total whole divided by n, where n is the total frequency. For example, find if there is any association between extravagance in father and extravagance in son from the following data. this extra vacant sun 327 741, that is Mr. sun 545 234. Determine the coefficient is of association also given, namely the extra vacants in sun and the fathers are not significant. This is one. Therefore, name the extra vacant sun. There is a significant at 5% level of significant. Degrees of freedom equal to r minus 1, that is into s minus 1. There are equal number of rows, s is number of columns. Find the chi-square test is equal to, that is chi-square values. Chi-square values equal to, that is 230.24. The calculator values in 1 degree subfreedom at 5% level is 3.841. Therefore, the calculator value is less than the table values. There is a significant difference between the attributes. Therefore, the coefficient of attributes AD minus BC whole divided by AD plus BC equal to minus 0.6814. And then second one problem, on the basis of information noted below, find out whether the new treatment is comparatively superior to the conventional one. Conventional new, favorable, not favorable. Favorable with the conventional 40, favorable with the new 16, the total 100. Non-favorable with the convention 70, non-favorable with the new 30, overall 100. Therefore, grand total equal to 200. Therefore, first of all, said the null hypothesis does not. There is no significant difference between the convention and the new treatment. Therefore, alternative hypothesis H1, there is a significant difference between the two treatments at 5% level of significance. Degrees of freedom at 1, the table values chi-square test that is 3.841. The calculator value of chi-square test equal to 18.1818. Therefore, the calculator value is 18 point something, table value is 13 point something. Therefore, the calculator value is greater than the table values at 5% level of significance. Therefore, the null hypothesis false. Null hypothesis false means that the alternative hypothesis proves. We conclude the treatment is not significantly. Then we conclude that the treatment is not independent. And third one, 1,000 students at a college level were graded according to their IQ and their economic condition. What conclusion can you draw from the following data? Economic condition, rich, poor, high, low. Therefore, first of all, to solve the problem, first set up the null hypothesis nothing not. Null hypothesis nothing not. The given attributes are independent. Alternative hypothesis, the given attributes are not independent. Degrees of freedom at 1% level of significance at 5% level values 3.841. The calculated values of ChiSquare is equal to 3.841. Therefore, the calculated value is 3.841. This table value is 3.841. Therefore, reject the null hypothesis if ChiSquare is greater than 3.841. The expected frequencies are calculated using the following formula. Expected frequency equal to the corresponding row total, the column total divided by current total. The expected frequency of 460, 420, the expected frequency of 140, 180, expected frequency of 240, 280, expected frequency of 160, 120. Therefore, the size square test are given below. From the table, the calculated values of size square test equal to 31.7373, table value is 3.841. Therefore, the calculated value size square greater than the table values. So, we reject the null hypothesis lecture not at 5% level of significance. Therefore, the conclusion, the attribute IQ as economic condition are not independent. And the last one, to the following data evidence of the effectiveness in inoculation is inoculation attacked, this not attacked. Answer, there is no effect of inoculation. Alternative hypothesis, there is a effect of inoculation at 5% level of significance. As per the given data, the calculated values of size square value is equal to 7.36, table value 3.841. Therefore, the calculated value is 7.36 greater than the table values. So, we reject the null hypothesis H0 at 5% level of significance. We conclude the treatment is not, are not independent. And the next one, out of 8,000 graduate in a town, 800 families are out of 1,600 graduates employ 120 families. Use I-square test if any distinction made appointment on the basis of sex values. Chi-square test at 5% level of significance for 1 degree of freedom is 3.84. There is no distinction is made appointment on the basis of sex. There is there is a significant distinctions made in the appointment of basis of sex. As per the given data, the calculated values of chi-square test 31.889. This table value is 3.841. Therefore, the calculated values greater than the table values. So, the conclusion null hypothesis H naught is rejected. Therefore, the conclusion IQ, economics contribution are not independent. Further, let us sum up keywords. What is the meaning of definition? Chi-square, contingent stable, and refer the further reading. Airlines DN Fundamental Law, Statistics, all above, hit by Maval. And next one, Gupta SC, Fundamental of Business Statistics. That's all over. You practice the following problem, try to solve based on the example and the given formula, try to solve this problem. Thank you.